Let me just hit present. And again, I think you can see my screen. Someone said earlier they could. So hopefully you should see a screen right now. I'm going to be presenting some slides, and hopefully you can hear my audio fine. Again, people said they could before, so hopefully it's working for you. This is a kind of a hands-on workshop about data annotation. We're going to cover the different types of labels and where they're used, and then we're going to go in, kind of create those labels in a tool and export that data set that you can then use in your own project. So the point of this is you're going to understand how to kind of label for all these different applications, and then you could go off and build your own. And like I was saying before we actually got started here, when I was learning computer vision, a lot of the times the material really just focused on tuning models, which is great, but also building a data set is one of the most important factors with computer vision and machine learning in general. So again, company that I work for and who builds the data annotation tool is Plainsight. We just rebranded to Sixskill. So if you see a couple links around with Sixskill, we rebranded from Sixskill. So if you see a couple links with Sixskill in it, that's why. And we're going to be also showing off not only how to label for all these different kinds of applications, but also how to use features like smart polygon selection, auto label to really label your data a lot faster. So if anyone has had experience doing kind of computer vision data sets before, hopefully some of these features will stand out to you and make you more excited about data labeling. Hit record. I already hit record, but I leave this note because often I forget. Set up, repeat for anyone who just came in. So if you want to follow along with the labeling, you can sign up for free here. Again, there's no card or anything required. So you can go ahead and create an account if you want to kind of start playing around with it. Now, what this workshop/demo is an introduction to data annotation and AI-powered labeling for computer vision. So we're going to cover how to create labels and data sets for object detection, instance segmentation, feature points, and classification. If you don't know what those are, don't worry. I'm going to cover them very briefly before we go into the hands-on portion. Again, though, feel free to ask questions as we go, and I'll be hanging out afterwards if you have any questions for me then. A tiny bit about me. My name is Sage Elliott. I'm a machine learning developer evangelist at Plainsight.ai. We do really cool stuff in machine learning, computer vision, and kind of connecting all those things to different devices. And we're making tools that make it easier for everyone to kind of build those applications. And I'm going to show part of that tool today, which is the data annotation piece. For about the past decade, I've worked in software and hardware, mainly with startups or small agencies around Seattle and then also Central Florida. And I really love making things with technology. If you want to stay connected with me, you can find me on Twitter at SageCodes. You can search LinkedIn for Sage Elliott, 2 L's and 2 T's. And you can find all my links at sageelliott.com. Tiny bit about you. If you want, again, I know chat can be kind of quiet, but if you want, it'd be cool if you posted, maybe where you're watching this from or why you're interested in computer vision or both of those things. And again, if you want to stay connected in a community after or with me afterwards, you can join the Slack channel. And I'm going to keep going though, but feel free to post in chat and connect with people. And again, one more time, just a repeat for anyone who just came in at the last 2 minutes. If you want to sign up for the annotation platform, you can do so there. All right, so why do you need labels for computer vision? Why do you need to annotate the data first? So computer vision isn't always tied to deep learning, but most of the applications that you've probably seen in like the last decade or so, they use deep learning behind the scenes. And most of the time it's a form of machine learning or deep learning called supervised learning, where when you're training a deep learning model, in this case, we're giving it images and telling it something about those images. And that's where the annotation piece comes in, or the labels come in. So if we were training a neural network, you could think of this F as a big function, and we're going to pass it in some training data, and then it's going to learn from that training data. And then hopefully we'd be able to pass in a new piece of data it's never seen before, and it can make a correct prediction on it. So in this case, if we're going to train our deep learning model just for, let's say, classification, we would give it all these images of geese, and we would say, hey, this image contains a goose. So learn features that kind of repeat over and over in images whenever a goose is there, and hopefully you'll learn how to detect a goose. So it could look at this, it'll probably look at hundreds or thousands of images for quite a bit, and kind of adjust parameters and then learn to detect those features. So then we'd give it a new image that it's never seen before, this other picture containing geese, and then hopefully our model would be accurate and give us the prediction that a goose was in that photo. So we'll talk about the different types, right? That was kind of an example of classification, but most of the computer vision applications or different types of models require different types of labels. So a lot of people start with classification. It's a kind of a backbone to a lot of things as well. But you might have seen object detection before. So object detection can classify and localize where an object is inside of image or video. So in this case, right, instead of just saying there's a goose in here, but we don't know where, one, we actually know how many geese are in here. It's 2, right? We could count them. But we're also saying like, I'm estimating that they're in this area here. I'm drawing a box around where I think the goose is. And this is really powerful because not only can we get the count of objects or have multiple objects in an image and kind of count them separately, we can also see where they are and how they interact with things. So for example, you can see that based on where this box is and this box is, that the geese are probably pretty close to each other. Or if this was on like a manufacturing conveyor belt or something, you could have a pick and place robotic arm know where the thing is and go and grab it, versus just the classification can tell you, does something exist in the image, yes or no? But it can't tell you exactly where it is. So object detection is kind of a really cool piece that you can do a lot of stuff with. And in order to label and train a model in it, you usually need to pass in what's called bounding boxes or rectangle labels. And it looks like the return prediction here, right? We're going to see an example of labeling this in a minute. But you're really just drawing bounding boxes around those objects that you're trying to train your neural network to detect. We have instant segmentation. So kind of like object detection, it can tell where something is in the image or the frame of the video, and also what it is. So it can classify and localize, but it can also almost kind of like localize better because instead of just drawing a box around it, which you can faintly see here, it's also drawing pixel by pixel exactly what it thinks belongs to that object. So here we're detecting these bottles, and we're also detecting water, and we're doing it pixel by pixel, saying this is where the water is, this is where the bottle is. And a cool thing about that is, one, it can be more accurate than just an object detection model a lot of the times. It can be a little bit heavier to run. So you have to think about like how you're deploying these models. Is it better to have something that's more accurate, or that's a little less fast? But also you can actually do now interactions between those pixels. So in this case, you could kind of do a volumetric calculation saying like, hey, this water level goes up to here. I see this many pixels of water versus this many pixels of bottle. So I could kind of calculate how full that bottle is. Or if you were doing it on like a hand and you're actually kind of painting pixel by pixel where the fingers are, if you're doing a augmented reality or virtual keyboard, you might use something like that to detect like exactly what key is pressed by a finger versus just doing like a bounding box around the entire hand. And then to label for that, you use something called polygons or masks, and we'll see how to do this, but it's usually much more labor intensive than just drawing those bounding boxes, because you actually have to really trace precisely around the object. So you can see here, the person biking is labeled, the bike is labeled, and the street is labeled. So it kind of feels like you're just really tracing around the objects. And again, we'll see a hands-on example of that in a minute, and how to make it way easier. We have feature points. You've probably seen these in either like pose estimation models as well as face applications. So you might see examples of it running on someone's face and drawing kind of dots around where the eyes are or where the mouth is and the shape of the mouth. So it can detect like mood or smile and expressions. And then it's very common in this kind of pose estimation. So here we're looking at the poses of people's bodies and then classifying what yoga posture they're in. And to label that, you kind of spread these dots around that kind of connect to each other. And again, we'll see hands-on of this as well. But you would start somewhere. You need to predefine like how many points you're going to have, like what makes up, in this case, the body structure. And we're starting with the wrist and then kind of going up the arm, and then you kind of get an output, something like this. So every one of these dots is really the label. And then you're going to build a model that kind of connects those together and can understand something like the body posture or facial expressions. And then classification, we kind of talked about this at the beginning, but the label for that is really, you're just saying, is this, like what kind of class does this belong to? So for example, I trained a model on dog breeds and I passed in, I forget how many dog breeds I had, like 130 or something like that. And each one of those belonged to its own class. So like Labrador Retriever. Here's one, a painting, and we could say, it has the class of painting, but you can also assign multiple classes to images, right? It could have class painting, but also the class of, in this case, done by Van Gogh. So you could have the artist and the painting. And that's really, there's different ways of kind of doing those labels, but like a common structure of that is if you just have one class, you could put it in a folder. And then when you read in your images with your model, you can figure out what folder they were in, and then kind of assign that class to them. We'll see an example of kind of a more organized way of labeling these as well. Just to mention, so the full computer vision lifecycle and kind of machine learning lifecycle for most cases, right? Like today, we're going to talk about the data annotation piece, but there's also device management where you need to manage kind of either cloud computing or edge devices, right? Like if you train a model and you deploy it onto a Jetson Nano out in the field, so it's actually doing the inference on images right there versus passing up to the cloud. Sensors, which would be cameras in this case, and then data collection. Once you're kind of collecting that data, how do you manage it? How do you create data sets from it? Sometimes if it's not directly from a sensor, maybe that's you scraping the web for something like images. Then you have the data annotation, where we actually label that and then feed it back or feed it into a machine learning model where we select what we're trying to do. So we need to select the model, we need to train it. And then once you have a trained model, then you have to deploy it. So there's all these different steps, like you're like, okay, cool, like I got my model, and then you might run to that last step of deployment can be really tough sometimes. And then depends on how you want to do it as well. Is it in the edge or is it on the cloud? And then you kind of often want to repeat this whole process over and over, depending on your application. But a good use case, how I describe that to people is like, if you were at I don't know if anyone's been to an Amazon Go before, but it's essentially a store that uses computer vision to kind of track you and see what you pick up. And then when you walk out, it just automatically charges you for it. But if you were to train a model to detect people and you only use data of people in the summer, people could be wearing shorts, maybe they have baseball caps, they're always in tank tops, they have flip-flops on. And then if you ran that same model on people in the winter, the people in the winter might be wearing bigger coats, scarves, bigger hats, long pants. Chances are that model would not be nearly as accurate on the winter data versus the summer data of people. So especially if you have kind of the seasonality of data, it's very important to kind of keep collecting and then keep training new models with more data and more variations of data. And we're building a platform to do all of that kind of in one place with a nice interface. And we're just going to talk about the data annotation piece of that today. But coming out really soon is kind of the next step of that platform. So I'm really excited next month probably to be showing that off to everyone. But if you do want kind of a demo of that right now, you can fill out the form at this contact link. All right, so let's go in. We're going to do hands-on portion now. And again, if you want to follow along, I'll paste this link in chat again. You can just sign up for an account there. And then if you want, you can even use the exact same samples that I'm going to use. This is just a folder with several different types of images that we're going to do different types of labeling on. But I also recommend to just try it on your own images. So you probably have a few images on your computer, or you could download some from the web and maybe they were more relevant to whatever your application actually might be. So if you can, I recommend just kind of bringing in your own data set. All right, so once you sign up, you'll have access to this tool. It'll look something like this. Might look a little bit different for you. Well, you won't have all these projects in there, so it'll probably be empty. And then what you want to do is just, we're going to hit new data set. So we're going to create a new data set. And this first one, I'm going to show off how to create a data set for object detection or instant segmentation. They're kind of similar. There's different labels like we talked about, but I'm going to combine them all kind of into one example here. So I'm going to just call this object detection. You would want your name to be relevant probably to what your project is, right? So if you were doing one for detecting lions, you could have it lions or lion bounding boxes or something like that. And then I'm going to hit save and continue to sources. For this one, I'm going to hit add source here, and I'm going to use local files. So I'm going to upload some local files here. but we also do support connecting to Amazon S3 as well as Google Cloud Storage. I'm going to go in, and I'm going to go into that. If you did download those images, I'm going to go to the segmentation and object detection example. I just upload these. And as these are uploading, you can see the progress here, but we can also just go ahead and go to the next step, which is starting to define our labels. So when you're defining your labels at this point, you kind of want to know what you're building, because if you want to do object detection, you need to know if you're going to do bounding boxes, or do you want to try out polygons for instance segmentation, or do you need to do feature points? So in this case, I'm going to make one called Goose. So this is me creating a label. You can select the label type right here. For this first one, I'm going to leave it as rectangle because I'm going to show off different examples for bounding boxes as well as polygons here. And then you can choose a color. This is really just for you as the labeler to make it easier. So I know that my geese kind of are in parks with a lot of green behind them. So I know that like blue will show up good. So I'm just going to select blue there. And then you can see there's this configuration option for auto label. I'm going to come back to this in a minute, but I'm just going to mention that you can configure this here, but I'm going to do it in the next screen. So I'm going to hit save. That is now our label for Goose bounding boxes. I'm going to make another one called Goose Polygon so I can show the difference between bounding boxes and polygons. And I'm going to hit that drop down, hit polygon here. Again, hit save. I'm going to adjust the color again. Hit save, and then I'm going to make one for cars. I'm going to call it car. This is also going to be a polygon. I tend to work with polygons a lot, and one reason I didn't before is they were such a pain to label because, again, you'll see how we do it manually. It takes a lot of time, but with some really cool AI powered tools, it makes it way, way faster. And now I actually use them quite a bit more because instant segmentation models are really cool and can be used for different things. But also, like I was saying, if you're not so much worried about the compute time for like the inference on them, they can actually tend to be a little bit more accurate as well. And then I'm going to make one more label for cups. I'll just do cup. This is also going to be a polygon. I'll go ahead and leave that color. So I hit save here. I've created all my sample labels that I want to right here. And you could keep adding more in. Also, just want to note, if you're kind of new to this, I wouldn't really recommend combining the different types of labels in one project like this. Here I have the rectangle and polygons. I would suggest sticking to one type unless you really know what you're doing. And once you export them, kind of how to break them out and use them in different models. Also, we have this spot here where we can add labeling instructions. I'm going to leave this blank right now, but this is great if you're working with a team and you have other people labeling and you want to say what to do, as well as you can embed specific images of like, this is a good example, this is a bad example. And that can actually be really important for even like you as the ML engineer or someone who knows the business, right? Like if I was labeling for a specific type of tumor or something and some healthcare data, chances are I wouldn't know what that looks like because I'm not a doctor. So I'd want a doctor to go through and do at least some samples of that and then provide it here so I can maybe reference them as I'm doing the kind of the data annotation. So really cool that it's a really great feature, especially if you're working with other people, but I'm going to go ahead and leave it blank for now. So I'm going to hit save and start labeling. This will bring up my images, and here you can zoom in and out with your scroll wheel, and you can kind of pan around by clicking and dragging. If you like accidentally pan way out and lose sight of the image, you can always hit this resize to fit, and that'll bring it back to the default view. So if you accidentally zoom way out, I have one of those scroll wheels that can just like really scroll really fast, and sometimes I'm like, oh, where'd it go? So you can hit this resize to fit. You can also adjust like appearances and rotate it. That doesn't actually do it to the data source, like the actual image, but it can help you, like if it's a really dark image and you want to lighten it up or something like that while you're doing the labeling portion, you can do that in here, which is kind of cool. If you have those instructions, you click this instruction button that brings that'll bring them up here. If I forgot what to do or I wanted to reference something. So let's go ahead and say that we're going to label these geese with bounding boxes, kind of the manual way for object detection. I'd want to come in, select my rectangle label here, and then you get this kind of crosshair that is helpful for kind of lining up where you're labeling. And then you want to be as close as possible to the object, but not inside of it, right? So something like this. And that would be my label for that goose. And then I would do this. And if you want to, you can hit escape. That'll unselect your label, and you can always come and edit these later. So if you need to move them around or make them bigger or something like that, you can do that as well. So pretty easy. If we were just labeling for object detection, I would just hit submit, and then we'd be done with this image, right? Not too bad. But let's go look and see what it's like for polygons. So polygons, I can select my polygon label here. And I'm not going to do a very good job with this because I'm going to do it very fast. But you want to be as accurate as possible here, just kind of with the bounding, like the bounding boxes, except for now we're kind of really tracing around this object, right? So this is, we're drawing that mask or polygon around it. And you can see this has already taken me way more time than it did to do the bounding boxes. And this is one reason why I did not use polygons that much for like hobby type projects or something, unless I really needed to. Because imagine trying to do this on hundreds of, and I didn't even do a great job there. Imagine trying to do that on hundreds of instances or thousands or a million in your data set. It takes a long time. So one of my favorite things, it was actually kind of, I think our first AI powered tool is smart polygon selection. So you can enable this right here, select your label again, and now you kind of get the crosshair like we did for bounding boxes. And what I'm going to do is draw just like I was going to do a bounding box. So again, I want to be very tight to the object I'm trying to label, and then just click. And did I not click? And then boom. So it'll automatically try to figure out the object that you're trying to label within that bounding box, and then just snap those polygons to it. So that's way faster than me manually drawing them, right? Let me do this on this goose. Oops. Okay, I did something weird. Do it there. And now you can actually see it wasn't perfect on this goose, right? If I zoom in, I can see it messed up right there. And that's okay. It got me like 80% of the way there. So just like with the bounding boxes, I can click on this and I can edit these labels, right? So one, I could highlight each node and actually hit the back button or the delete button and get rid of it, or I can drag them around. So I could see why the model would mess up here, because again, remember, this wasn't trained on specifically geese or anything. It was just saying, I'm trying to figure out where the object is that you drew that box around. And so in this case, if I zoom way in, I kind of have a hard time telling what's the goose or the sidewalk. So again, you can come up and fix this one as well. So if this got me like 80% of the way there or 90% of the way there on my data, that already saved me a ton of time as well. And boom. So then from here, we would hit submit, and then we would be done with this image. Oh, and I should note too, so if you're doing object detection or instance segmentation and you've never labeled for it before, you pretty much always want to do all the instances in the image. So if we were doing bounding boxes and I only labeled this goose, and then I gave this to my model to learn what we're looking for, it would be very confused, because it would be looking for these features and say, yeah, I think I'm learning about something in here. But then it would say, well, you didn't say this was a goose either. So now I'm really thrown off. So you really want to make sure you label all the instances of the objects in your image. One caveat to that might be is if there's a goose way in the background and it's really small and kind of looks way different to you, then it might be okay not to label it, but just don't expect your model to learn how to detect a goose at that size. So another cool feature here, let's go back, let's turn on auto label. So this will automatically apply labels to our images. And currently you can select from 81 pre-trained classes. And there isn't one for geese, but there is one for bird. So this should work on our geese here. And then coming very soon, this is where this gets really, really powerful, is you'll be able to train your own model using your own data set and then tie it back into auto label and then kind of have it actually do most of the labeling for you. And you're really just kind of QAing it at that point, hopefully. So right now, drop down is just the Cocoa data set, but coming soon is you're going to be able to tie in your own model, which is going to be awesome. So I'm going to turn this on for bird, hit OK. And it's applying auto label. You can see it drew the boxes around it. If this wasn't good for, if it wasn't good on this, I could, again, adjust it. So if it's like, if this gets me 80% of the way there, awesome, a huge time saver. So now auto label is still on. Again, you can enable it and this little drop down, and then you can kind of turn it on and off by clicking this. Now it's on, I'm going to hit submit. It's going to go to the next image, and it's going to automatically apply those labels to the next image as well. So this is really cool because really, like I was saying, it's just kind of doing the labeling for me, and I'm QAing it, kind of making sure that it did a good job as I go. So then I can hit submit and be done with this image. And again, I could come in and adjust this. So I'm going to turn this off and we'll hit submit, and that'll be that for the goose example. Let's look at another example of doing it for cars. So this one is polygons, not object detection. I'm going to enable the auto label again. And here I know that there's one for car in here. There's also one for truck. And I think there's one for motorcycle. So this would be me like building a, a data set of all the things I might see on this highway. And if any of these, like a truck shows up, I want to label it as a car in this case. So I'm going to hit OK. It's going to turn it on. And it applied my polygon or a polygon label to this car here. And I'm like, yep, that looks pretty good. So I'm going to hit submit. Looks good. Again, this is like so much faster than manually drawing those polygons around, right? Has anyone done like data annotation like the polygons before? So you can see, because this was a pre-trained model, it's not going to be perfect on all the angles of the data. If there is such thing as a perfect model on just all this different types of classes, then you wouldn't need to label your own data set. So here you can see for this specific angle, it just didn't get this car. So I'm going to go ahead and I selected that smart polygon. I'm going to label the car there and we'll label this front of the car here. I think I kind of messed up. I wasn't very tight around the car. So I can get a little lazy sometimes, but you want to be very precise around it, just like if you were labeling for object detection. And it got that car, but it didn't get this other one. Or I think I labeled those maybe with the wrong label last time anyway. Anyway, I would have selected the car one. I think I labeled it as a cup. That's okay for our purpose here. Hit submit. And then now it's working again on these specific angles. And so we just labeled, I forget how many frames that it was, something like 10 frames, incredibly quickly, all with polygons. And especially if you have multiple instances, right? Like if you're doing one instance per image, that's one thing. But if you have like 20 different cars and you can use auto label to automatically label all of them, that's a huge time saver. So one more kind of AI powered feature for the instance segmentation and object detection I'm going to show is something called track forward. So I'm going to take this cup label. I'm going to go ahead and turn on track forward. I'll talk more about it in a second. And then I'm going to use smart polygon again to actually do the label here. We draw that bounding box and oops, there. I think I'm doing just a bad job of being precise with my bounding boxes right now. But again, most of the way there, that's fine. You can go in and fix it very easily. And now we have track forward is enabled, and track forward isn't trained on any specific object like auto label is. What it's actually doing is it's looking at the object we labeled, like trying to understand what we labeled. And then it's going to look for that same object in the next frame. So this is great if you have a sequence of videos. Or frames from a video. So in this case, there's cups and the camera is going to kind of pan around it. You'll see like, they're not going to move a ton per frame. And this is when that tends to really work best is if it's a sequence of frames from a video with an object moving across it. So I'm going to go ahead and hit submit. And you can see didn't move that much, but the labels are still on the cups and they are moving around. So instead of, again, labeling every frame, I can really just turn on track forward here, hopefully do a couple labels, and then it should track them across kind of all the video. And then again, if I need to edit it, if it wasn't perfect, I could go ahead and do that. So again, if it gets you like 80% of the way there, massive time saver. And one more of the cup. Then I think I accidentally left in this PCB. I didn't make a label for it. That's okay. So we won't label this image right now. Once we're done, we're ready to export our data. We can go to review. The review step's really great. Again, if you're working with a team and you want to make sure that the data is labeled how you wanted it to be labeled, you can kind of, coming soon, you'll see the preview right in here of the label that's not on there right now. But you can go back to the labeler here And this is kind of how you navigate the different states of images. So right now, by default, it's showing pending, and we only have one image left. We could look at all images, and we could look at submitted images. So easy way to go and do kind of approval process is to select submitted. And then I could say, yeah, this looks good to me. This looks good to me. This looks good. Normally, if I'm the one labeling the data set myself for like my own project, I'm not going to go ahead and then approve all the labels I just did, because I know they were good enough for my project. So I can just go ahead and hit export here. And you'll just want to make sure you scroll down a tiny bit and make sure you hit submitted annotations, this checkbox here, because by default, it only exports the approved ones. That's because in most enterprise settings, you do have someone doing kind of a QA on the data before you export it. So just by default, it's not going to do all of the images unless they were approved. And you can hit this button here. So if you're doing this for your own project, you'll want to click that. And then we have different types of data formats. So if you've worked in computer vision before, you've probably used some of these. Cocoa data sets, probably the one I work with the most outside of our own JSON format. And this is great because most frameworks like PyTorch or TensorFlow, they already have a function that knows how to read in a Cocoa data set. So if you haven't done this before and you're looking to get started, chances are, you might go through some sort of TensorFlow tutorial or PyTorch tutorial, and they'll talk about bringing in, it'll probably be a Cocoa data set because there's pre-built functions for it, which is pretty cool. And then I would just hit export now. One other quick note. So you can do your train, test, and validation split here. If you've done deep learning or machine learning before, you probably know what this is. If you don't, it's really just you're using most of the data, in this case, 80%, to train your model. But then as you're training your model, you want to validate that it's actually kind of generalizing and can make predictions on images it's never seen before. So that's where you use your validation data set. And then kind of after you feel confident in your model, you can use it on another holdout test data set. So most of the data is used for training, and then you have some testing data sets to kind of look at along the way to verify that your model actually is learning what it's supposed to be learning. So I just hit export now if I want to do all submitted annotations in the Cocoa format with this split. I would hit export. It says export completed. You'll get an email with a download button. And then you can also, you'll get a notification here. It can take a few seconds to show up. So if I just refresh it, it should be there. But it's a push notification. It says my export is available, so I can download it. And then once you download it, you'll get a folder with 3 JSON files. This is what the networks are going to read in and then kind of parse through to understand your labels. So we'll look at one in a second. And then you have this IMG folder. This contains all the images we annotated. So we'll look at this JSON file, and it'll then reference back to those images in that folder. And then don't worry, this looks crazy. You don't need to know how to read it. But really what this is, we drew those rectangles. These are coordinates of those rectangles, and then they're referenced to each image. So when PyTorch or whatever framework you're using reads them in, it'll know to load that image in and then only look at that part of the image to kind of train the network. So that's the example of doing it for object detection and instant segmentation. Does anyone have any questions about that? Otherwise, I'll just go ahead and we'll go and do a classification example, and then we'll do a feature point example. Hopefully, if you've never done it before, or if you have done it before, hopefully seeing some of the features makes it less daunting as well. Like if you can use auto label for most of your labeling needs, labeling just got way easier. So I don't see any questions yet. So I'm going to go ahead and hit a new data set. We'll go ahead and do our classification one. I'm just going to call it class right now. Hit save and continue. Again, I'm just going to upload a local file or local files. Go back one in that data set, and I will get these 3 images just to show labeling 3 different classes. Go to my label definitions. For label type here, I want to hit classification. We also have multi-classification. I can talk about that in a second, but the classification is going to be assigning 1 class to it. So we're going to create a label called animal, and we can assign it a dog, a cat, or a bunny. If you had multi-classification, you could assign multiple classes to it. So if we didn't know it was an animal in this case, we could say it is an animal, it's also a dog. Or you could say it's a dog, it's also a Labrador Retriever. So if you wanted to assign multiple classes to one image, you could do it. I'm going to select just classification right now and just assign one class to the image. And I'm going to call it animals. And then to create the different classes here, you just type in what you want and then hit enter. So I'm going to type in dog, enter, and you see it kind of create a little tag like that. And then I'm going to type in bunny, enter, and then I'm going to type in cat, enter. And you can also select which one will be selected by default. So as you're labeling, this can kind of help speed up a little bit, because I can say, hey, by default, it's going to be a dog, and I won't have to go select it. I just know it's going to be a dog if I don't change it. So I'm going to hit save. Again, you have the instruction piece. We're going to skip for now. Save and start labeling. And here is a baby bunny. So I'm going to click on this drop down and select bunny, kind of this radio button here. And I'm going to hit submit. And here's a cat. So I'm going to hit this drop down, hit a cat. The cat's coding, by the way. And then there's a dog. Again, by default, I know it's a dog, so I actually wouldn't have to go here. I could just say, cool, I know it's a dog. I'm going to go ahead and hit submit. So again, you can go to export and then export it in one of the formats to be used for classification. In this case, you can use the sense.json format, which is kind of just a generic JSON, and you can build a data loader in TensorFlow or PyTorch to kind of parse it out. You could also use the create ML classifier structure, which is actually pretty good and can be handled by most neural networks as well. I think for most of the packages like TensorFlow, it really just comes out in a structure where these are in separate folders for their classes. So I'd hit export, and then I would be done there. And let's go do feature points real quick. A little data set of 3 images of hands and local file. Go back one, and we will upload these. Done. Go to label definitions. I will say hands, could be fingers or finger points or something like that, depending on what you're doing. We're going to select feature points. And then these 2 colors here are really for you to see kind of your progression of points. So by default, in this case, it's going to start like my first dot in order is going to be at this kind of deep purple, and then I'll make it change to a green. So you'll see what I mean as we label these. So I'm going to make 10 points. Again, you'll want to know how many points your model is going to be expecting or to learn from. So we're going to do 10. We're going to label like the top of the finger and then kind of the finger in the palm. And we could kind of train a network to look at some very basic hand gestures. So I'll hit save. See this gradient. We'll go to save and start labeling. And then here I would select my label, just like we did before. And then in this case, right, I was saying maybe we do like the top of the finger and then to the bottom of wherever the finger is in the palm. And we could build something that could look at kind of the postures of these. So again, maybe it's for like an AR application. And when you pinch, that's a specific command. Like if you've ever used the HoloLens or anything like that before, they'll be using something kind of like this to look at the position of fingers to each other and then do some sort of action based on that. So I'll hit submit. And then an important thing too is to always label each point with the same in each image. So in the last one, right, my first point was his thumb. It should be the first point in this one again, and so on. So you kind of see the gradient changes slightly, so you can kind of keep track of that. It's not always a huge difference. So if you need to see the number too, you can deselect in the label, just hit escape. And then you can hover over this, so it'll tell you which one is what. So if you forgot, you're like, did I put the right one there? The one is the thumb. And that also could be something really useful to put in the instructions, right? So as you're going, if you forgot which key point went to what part of the body, you might want to do that. Just do one more. submit, and then you would just go export like we did before, one of these formats that works well for you. And that is kind of all the examples of those different different labels for all those different computer vision applications we talked about. So I'm going to go ahead and stop the recording. Hopefully either you learned something new about computer vision, or you saw some new ways of doing data annotation, even if you've done it before, and hopefully it will save you a lot of time in your labeling process. So I'm going to stop the recording, but I will be hanging out for questions in the workshop.